We've looked at the graph of a basic sine and cosine function, but you're rarely going to see just a regular sine or cosine function in applications that you're going to deal with. Rather, these functions are going to be stretched, compressed, shifted, all sorts of things. So what we're going to do, we're going to define a couple of terms here. We're going to begin with what's called amplitude. And amplitude is how much the original wave is stretched or compressed. If you look at a function, so f of x equal to a sine of x, or perhaps you have g of x equal to a cosine of x, the amplitude is simply equal to the absolute value of a, whatever number you're multiplying it by. The next thing that we can change is, suppose that we have some f of x is equal to sine of bx, or g of x is equal to cosine of bx. The role that that b value is it changes the frequency of how often the function repeats. Remember, we talked about the period of sine and cosine being 2 pi, but if we multiply that value by some number, it's either going to make it happen more quickly or less quickly, depending on if it's a fraction or not. So what we do is we define what's called the frequency, or how often the function repeats, to be b over 2 pi. The period is actually the reciprocal of the frequency, and the period is calculated by 2 pi over b. Notice that if b is 1, then we have something like the cosine of x still. And so that 2 pi over 1 stays 2 pi, and our frequency remains what we determined originally. Let's do a couple of examples of these and move this picture down because we'll be using it later. But let's consider something like, what if we wanted to take something like f of x is equal to -1/2 cosine of 2 pi x. Based on these values we just determined, we know that the amplitude is going to be the absolute value of -1/2, or just 1/2. In other words, this original sine wave will no longer go between 1 and -1. It will shrink to go between 1/2 and -1/2. And the frequency is going to be 2 pi over 2 pi in this case, which is just 1. In other words, every 1 unit it will have repeated 1 cycle. One of the places this may come into play for an application is, consider something like perhaps a cello. We know that the strings of a cello are tuned to certain values. And so if we look at something like the A string of a cello, has a frequency of 220 hertz, and that just means cycles per second. That means that 220 cycles happen per second as that string vibrates, and we can change this into the length of 1 cycle. Remember, the frequency and the period are reciprocals of each other, so we can do 1 divided by 220, and what we discover is that in 0.00455 seconds, that 1 vibration of the string occurs. The last thing I want to show you is what can happen if we shift or have a phase shift in the sine or cosine function. So if we consider f of x is equal to a sine of bx minus c, so we're adding all the pieces in now together, or g of x is equal to a cosine of bx minus c. We already defined the amplitude is the absolute value of a. The period is 2 pi over b, or the frequency is b over 2 pi. And then the phase shift is equal to c over b. Well, what does that mean? That's where this picture is going to come in. Let me move my picture down one more time. If we consider the idea of the graph of f of x equals -2 cosine of pi x minus pi, we can determine that the amplitude is going to be 2. So it's going to range between -2 and 2. We can determine that the period is going to be 2 pi over pi because of our b value, which results in a value of 2. And our phase shift is equal to c, which in this case is just pi, because it's minus c, pi over pi, or a shift of 1 to the right. And what that results in is this graph here, where we can see that it has adjusted to going between 2 and -2 now. Notice that our original graph has shifted 1 to the right if we looked at an original cosine curve. And then we can also see that the period is no longer 2 pi, but rather it repeats every 2 units. As a last example of that, consider this graph where we have 1 plus the sine of x minus pi over 4. Notice the amplitude does not change because our a value is 1. The frequency does not change, but we do have a shift of pi over 4 to the right. And this value out front shifts everything up 1. So instead of going from -1 to 1, it's going to go from 0 to 2. Pay attention to those shifts, the frequency and amplitude changes, and make sure you practice with those a little bit. I highly recommend the Desmos graphing calculator. You cannot use it on a test, but it's a good way to play with things as you're trying to picture what's happening and develop your concepts. If I can be of any help, let me know.